go to some new technology that we're producing, which allows AI agents like Claude Code to interact with time travel debugging with Java and using undo technology. So what we've done is whereas traditionally use IntelliJ to talk JDWP to a time travel recording, what we're doing now is we've got Claude Code hooked up via MCP protocol, and we've got various commands, the usual kind of things for navigating debugging tools, set breakpoints, step over, reverse continue, etc. And we've got a new tool called LR4J MCP, which talks to the recording instead. We're just going to go to our standard concurrent modification exception demo. And we're going to do this blind, by the way, so Claude won't actually see the code. So we've got two threads. One is just looping over a list, and another one, mutated thread, is modifying the list. Eventually it throws concurrent modification exception. And like I say, Claude cannot see the code, so we're going to ask Claude to try and figure out what went wrong. Here is the here's the code. So we'll run Claude in this empty directory. The only thing it's got access to is an MCP server connected to a recording that we made earlier. So if I type MCP, we can see it's connected to our undo server. The arguments we've given it are the name of the recording and a key file. And we've got various tools: set breakpoint, set exception breakpoint, step into, reverse, concurrent modification exception. So I want to ask it to read the console messages, because down here you can see that that we print out a message when it goes wrong. So it very quickly reads console messages. It says it's iterating through, so now it's going to try and figure out in more detail how that happened. So it knows how to set an exception breakpoint. That's the start of the recording. Continue forwards, waits for it to stop. And that's the first part of the analysis. But what we're going to do now is we're just going to go a little bit beyond that. So we're going to prompt it to find the culprit. So we're going to say, please go back and find the culprit. Because so far it's just gone back to where the exception was thrown. But we still don't know exactly what caused it, who the mutator was. So we'll say, please go back and find the culprit. So it knows that it needs a set of watch points because it knows about Java internals. So it knows how Java works internally. It knows that how concurrent modification exception is thrown, the fact that mod count is compared against expected mod count inside this Java library class. So it's figured that out. It set the watch point. It's going backwards. And it's found a culprit. And there you go. So it knows exactly what went wrong at the mutated thread, even though it can't actually see the code. It knows exactly what's happening. We can ask it to show the stack here. And there we have it. So If we go and look, that's line 60. So here we go, we're doing the list.add. So Claude figured that out by itself, more or less.